Hello YouTube, hi, this is Fahad from Future Phones, and today we have a MacBook Air to repair. The fault with this MacBook is it's got no backlight on it. We will go through what the problem is, we will diagnose it, and then we will see if we can fix it. Let's give it some power first. The power supply I have is set to 16.5 and 3.57 amps. I'll give some power and we will see if the problem is there. So I will keep it like this, and I don't know if you can see this, but I will try and show you. So you can see there is an Apple logo in the back. If you see in that screen in the left corner, there is actually is a right bottom right. So you see the Apple logo there. If I remove my torch away, so there is no backlight. So let's see what the problem is. For the backlight, we have I've got the schematics open, and we will just go through the schematics and check what circuitry is involved in creating the backlight. Let me just remove this power. Okay, so this is the power that we need. PPHVF S5 SOSW LCD backlight, which goes to the LVDS connector. Let me just open the LVDS connector. Are we on the let me just take you there first. Desktop. Yeah, okay, so we are going to the LVDS connector here, and these two pins are the pins where the power for the backlight comes, and the signal name is PPHV SOSW LCD backlight, and it's supposed to receive if in good condition it's supposed to receive 27 volts. If it's 0 volt, then means the circuitry is not working completely. If it is higher than 27, which could be like from 39 to 48 volts, there could be a problem with the LCD itself, where the backlight is not receiving the power which it should. The boost circuit is providing the power in the hope that the LCD receives some power, backlight receives some power, but if it doesn't receive, then it will keep pumping in the power. It will happen only in case if the LCD backlight is faulty. So then you will have higher voltage. If your LCD backlight is okay, then you should receive up to 27 volts. If it is between 8.5 or 12 volt, then that means the circuit for the boosting is not working properly. So let's see what is all this circuit about. So this is the circuit. So it starts from PP bus G3 hot here, and this PP bus G3 hot is a 8.6 volt line. It goes through a fuse, and then we have a voltage divider. That voltage divider will enable this MOSFET Q7706. So to get this voltage divider working, we need to give a ground to the R7789, but the ground is here over in this if you look at it, Q7707, and we have a ground on pin number 1. So we have to transfer this ground to R7789, and this will only happen when you have EDP backlight enable signal coming, and you will also have the backlight PLT reset _L signal coming. If these two signals come, then your ground will shift here first, and then again it will shift here to LCD backlight enable _L. So once the ground is shifted here to this signal, so or this resistor, pin number 2 of this resistor, if you have a ground available, then this voltage divider will work, and it will switch this MOSFET and by switching this MOSFET you will get the 8.6 volt here again, right? So we will check this. Once we have a 8.6 volt here, then this 8.6 volt comes here. If you look here, it's next to the C7712 and C7713, and we have a coil here, and this coil is connected to SW_0 and SW_1, and this IC is U7701, which is a driver IC, and it will give the you can say that it will give the higher, or it will boost this 8.6 volt to 27 volt. So we need all these things in the working condition if we need 27 volt. So we need to have this MOSFET working so that the 8.6 volt from PP bus G3 hot comes to here, and once this comes here, then 8.6 volt is available here, and this 8.6 volt will be boosted by this U7701, and this will be boosted to LCD backlight boost. Once we have a boosted voltage here, so it can be up to 50 volt. So you can see that from 8.6, which will be here available, LCD PPWin SOSW LCD backlight, and this will be boosted to up to 50 volt. So how this IC boosts is very simple. If you can see here, so we have two always powers available, which is the first one is PP5VSO. This PP5VSO is a 5 volt line in the S0 state, so this will provide 5 volt here. And then we have a PP3V3SO, which is a VDD-IO, so this is a 3.3 volt line, and this will be available at pin C4 of this IC. So once we have these two powers available here, then we have to look for this power, which is the PWM, backlight power management and backlight enable. So if these two are available, then this IC in practical it should work, and it should boost the power. So it will provide a switching supply here. So it will be, if you look in the DSO, this power here SW0, so it will be in a waveform, and it's like going up and down. So this is the boost circuit. This is how it works. It will be switching supply, so it will add, let's say if the LCD requires 27 volts, so we are getting 8.6 volt from here, and the rest of the power will be coming from the SW line here. So SW line will provide rest of the voltage. Let's say if we need 27 volt, then 8.6 is coming from here, and 19 volt will be available at this switching power supply. So 19 volt switching power supply and the 8.6 will be merged, and they will become a 27 volt, but that will be in a waveform again, because it's a mix of switching power supply and the DC power which is coming from this coil. But when it goes through this diode, so it will be a DC, straight smooth DC again, which will be 27 volt as required by the LCD backlight. So it could be less or more depending on what the requirement is. If there is a fault, then there will be 8.6 volt only available, or it could be only 0 volt available. In the good working condition, it will be 27 volt. Now the thing is, with this circuit, this will be visible. This will be visible when the LCD connector has, or LVDS connector has the LCD connected to it, because if there is a load, then this switching power supply will work. Otherwise, this switching power supply will see as if there is no requirement, and it won't give any power. So this is all the theory behind it, and if there is any other signal that is worth mentioning, let me just check. So it's a PWM EDP backlight power management, which is this one here. This is coming, and EDP power management is coming from the SoC. You can see here pin number 708. So the SoC knows that LCD is connected, and this is why this is when it will enable this signal. This signal will be enabled by the EDP backlight. Enable will be enabled by the SoC. See, this EDP backlight enable has only this point, which is in the dual transistor here. So let's talk about this one, because this is an interesting signal. So this signal is at number 5. You can see that. So once it receives 3.3 volt at pin number 5, so what it will do, it will transfer the ground from here, LCD backlight disable, to LCD backlight enable. So the SoC is giving instruction that enable the LCD backlight circuit. So once this is enabled, then 8.6 will travel here. So this is all the theory behind it, and let's see what is the condition, because this this circuitry needs the LCD connected. So I will test it with LCD connected, and it's gonna be very awkward anyway, so but I will try. Let's see, and we will see what sort of voltage we have available. Let me go into the microscope, and microscope is here. So my LCD is connected. You can see the LCD connector here. This is connected. So we are supposed to receive 8.6 volt 27 volt at this point in the working condition. So I'll just connect the power, and we will check what sort of voltage is available. Let me just put my multimeter in the DC range. Yep. Okay, let's check it, what we are receiving. So we are receiving 8.5. So it's not boosting. So we are receiving 8.6 volt, but it is not boosting. Okay, let's check the Q770 pins that we were talking about, which is on the which is this transistor here, 6 lag IC. We will check this. Let me just open this up. So on Q770 is okay, I don't know if you can see the microscope in the, I'm quite sure you can see. Okay, let me go to the desktop. Yep. Okay, so we are looking at the Q707. So we need to see those two signals if they are providing, because it is a working condition. You can see the 8.6 from PP bus G3 hot has transferred successfully to this area, and this is here also. So let me just tell you how. So we are looking at this fuse first, which is F770. So F770 pin number 1 is this one, and we are receiving 8.57 volt. I think you can't see the multimeter. Just 1 minute. Okay, let's check. I think you can see the multimeter on the screen. So my multimeter is in the DC range. So we are looking at this fuse first, which is F770. So we are receiving 8.6 volt on this point, and we are receiving 8.6 here also. So our the fuse is good. Now this is the voltage divider. If this voltage divider receives a ground at pin number 2 of R7789, this MOSFET should work, Q7706, and we should receive 8.6 volt here. So let's see where is this MOSFET. So which is Q7706. So Q7706 pin number 1256, we should receive 8.56. so if we receive 8.56 on this point, okay, is it off? Yes, the laptop is off now. Okay. Okay, why is it not receiving power? Is it receiving power? Yep, it's on now. So we have a 8.6 here, 8.6 here, and this is the supply to the 8.6 to here. This is the gate voltage 2.87. so our voltage divider using this resistor, and this cap, which is in the circuit R778 and R7789, they are working. That's why we are receiving here. If you want to check, you can check in the voltage divider there is a few websites you can just put the data in and you can see if this is working fine. So we have a voltage divider here, so 2.79, which is good. So, and we should receive here 8.6 again. So we have received 8.6 here, and after this 8.6 is, it goes to the C7712, which is here, the small capacitor. So we will look into that. So C7712, it's not small, it's a big cap. 8.6 is available here, and then we have another capacitor C7713. we'll leave this one. We go to the L7701. we will check here what is the condition here. So we have on pin number 1 of this coil L7701, we have 8.6. so on this side of the coil we should have a higher voltage as per the circuit, but we are not receiving a higher voltage here. So if we are not receiving the higher voltage, let me just take this power off and I will remove this also. Now I'm going to test the U7701. we will see, let's check in the microscope what is the position for the L7701 and what is the condition. So U7701, let me just click on that. So this is the IC on the back side of the board, and this is the driver IC that boosts the voltage. Let's see where it is. I think it's here. Okay, so you can see this is the driver IC. Let me just go into the microscope. You can see the state of this IC. So this IC definitely has had its time. So I think instead of checking anything else, because it's physically damaged, so I will just remove this IC and we will take it from there. We will just change this IC. I think I have them available. Okay, so my hot air station is set to 497. I'll just remove this IC. So this is, once we have removed this IC, we should be able to receive a higher voltage at that coil where we receive the 8.6 voltage. Come on. Let me just clean it with a little bit more flux. Okay, those two resistors are disturbed, so we will fix them. Now what we need is cleaning. Clean this. Okay, one of the pad is missing also in the middle. Let's check which pad it is and what it does. I hope it's not, it's an NC pad, then it's fine. Or if it is missing or not missing, let's check it. It's discolored, so it's not missing. Oh, it's not missing. Okay, let's get the IC out. This is a brand new IC. This is our backlight driver IC that will boost 8.6 volt to 27 volts. Okay. Let me just warm up this area a little bit. Sorry, it's just don't know why it's not focusing. Is it focus now? Good. Okay. Oh, my eyepiece is gone. Just 1 minute, let me just refocus it. Okay, let's put this IC. Just put this IC first. Okay, I think it will adjust itself from this point. Yep. I'll just give it a nudge. Okay, let's fix these resistors also. Okay, let's just adjust these resistors. Sorry, I had a customer, so I had to pause this video. So these resistors are in line now. Okay, that's enough. So resistors are okay, IC is okay. I'll just give it a clean, let it cool down. Okay, that's okay now. So this is the faulty IC, you can see it's all burnt, so no wonder it was not boosting those signals. Let's see, we have changed this driver IC. Now we will go back to the other camera. Let's face this one, and I will connect LCD and we'll see if we can get a display out of it. God, this is an awkward condition. Okay. sorry guys. Okay, let's put it this way. Okay, LCD connector is in. Move it away from here, and I'll put it this way so you can see if we have fixed it. So let's give the power. Hopefully we have a display. Yep, something has happened. Okay, we have an Apple logo. Look, we have the Apple logo here. So the backlight is fixed. That's good news. Okay, let's check the voltage on the coil and that LVDS connector, if we are getting the right voltage. Put it this way. Wait. I think I can put it this way, and I can just move it around so I can get a good view. Okay, let's give the power and let's check the voltages. So we were expecting to 27 volts at this coil. Sorry, let me just move to the microscope. So are we receiving that voltage here now? You see that 24 volt, which is okay because the lid is closed. If we open, as per the requirement, the voltage will go higher, and you can see on this coil 8.76, and but if you look at this diode, there will be higher voltage. So this is fixed. So we can't see the higher voltage at this coil because the rest of the voltage is in the switching form. So we can check that with the DSO. However, we can't check it this with this multimeter here. But after this diode, because the diode is filtering the switching power and the DC power into a smooth DC, so at this point you can see we have a higher voltage now. Let me just open this lid and see if we can get 27 volts. Let me just yep, 20 volts, 19, 18, 24, and we are receiving 24 volt, but we have a logo. So I will give it a close. I'm quite sure this is fixed. Okay, I have checked it. Actually, there is Apple logo is still loading up. So if it was a full display, then we should receive higher voltage. Let me just check. If we do now, it's still receiving 24 volts, but we have a good backlight here. So I think it only requires 24 volt to display the Apple logo. I'll pause it, let the computer power on completely. So yes, the LCD has lit up, and we were receiving 24 volts before, and now we are receiving 25.77 volt. So obviously, as per the requirement, the requirement, the voltage is increasing. It was 24 before, now is about 26. So we are okay with this one now. I think this we have fixed this one, and I hope you have learned something from this one. The logic behind the backlight circuit is very important. You must learn it, because by changing the driver IC, if you fail, I mean, if you change the driver IC and still there is no backlight, then you must know what the circuit is all about. So if you know the circuit, then you can fix it. So thank you for watching. I hope you have learned something from this video. Do like and subscribe to the channel, and if you have any questions, you can leave it in the comments. Thank you very much. Thank you for watching. See you in the next video.